good afternoon.
Hello.
Hello, welcome back, guys.
Hey, Miss.
So we're working on 10.6 today. Last time we were together, we did 10.5. We talked about tangents. These were lines that hit a circle in only one spot. Today, we're going to talk about tangent's cousin, the secant. I know it's spelled secant, right? Like, I just can't, right? But it's pronounced secant. I don't know why. English is weird. All right, so let's get some definitions out of the way. Let's start with our new word, our secant. All right, so the secant is going to be a line, and this line is going to intersect, and it intersects a circle, and it does this at exactly 2 points. So let's draw what this thing looks like. Okay, so YOLO a circle, and let's give that circle a name. H. All right, and then we're going to draw a secant. This is going to be a straight line, and it's going to intersect the circle in exactly 2 spots. No one cares where, okay? Just any 2 spots. YOLO, that looks like a good spot. All right, I need some names. I'm going to need 3 letters. Go.
John.
I heard J for John.
X.
X. And one more letter?
P.
P. All right. So, to name this secant,
What's that top letter?
it's a lowercase cursive J. So make your J cursive-y and make it lowercase. So give it a... Yes, it has to be cursive, otherwise it's not named properly. Remember that points are named with capital print letters, and lines can be named with lowercase cursive
You
letters.
can get it marked wrong if you don't write it cursive.
Yes, because you're not
What?
giving me the name of a line, you're giving me something else. Yeah. All right, so I can write the name of the secant as line XP. I can use the 2 points that are on this line in order to name the line. Okay, so this line is secant to circle H. Or I can write the word line, and then I'm going to use that lowercase cursive letter. Line J is secant to circle H. You could write that either way and still be correct. Where? This is the word secant. Okay? So you can write line XP is secant to circle H, or line J is secant to circle H. All right, we've got 3 theorems, and we're going to give them kind of shortcut names almost immediately, and it'll describe the kind of figure that we're looking at, okay? So our first theorem is going to be called 2 secants outside. That sounds like the start of a joke. Oh, excuse me, inside. 2 secants inside.
So 2 secants inside.
Inside. That's the name of this theorem.
The next thing you knew, there was 3.
All right. The theorem says, if 2 secants or chords intersect in the interior of a circle, then. We'll get to the then in a second. Let's draw the setup first, okay? I need 2 secants, and I need them to intersect inside of a circle, which means I have to have a circle. So draw a circle. We don't need a center, so we're going to leave the center blank. But we are going to throw in 2 secants, and those secants can intersect anywhere you want them to in the circle. There we go. That looks good. Kind of looks like the X-Men symbol. All right, there it is. And then I need some names of points. Can I have 4 letters from 4 people who haven't had a chance to give letters yet? I heard a J.
P.
I heard a P and I heard a D. And then in the S, and then we'll hang on to yours in a second, okay? So hang on to it. We'll use that on the next one. All right. And then I'm going to label angles. And I'm just going to use numbers. Okay, here's angle 1 and here's angle 2. Okay? This theorem gives us 2 formulas, and it just depends on which direction you're looking at, which angle you're looking at, as to which formula you use. Okay? Let's say for a moment that we're looking at it from angle 1. Okay? So the measure of angle 1, that's this one. The measure of that angle is half of whatever you get when you add up the measures of these arcs that got created by these secants. Okay? So the measure of arc JP plus the measure of arc SD. Add those arc measurements together, divide them by 2, and that will give you the measure of this angle here. It also gives you the measure of the angle across from it, because they're vertical angles, and vertical angles are congruent. Okay? This also gives us SD, yes. All right. We can also use this to get a formula for angle 2. It's going to be the same kind of concept. Okay? So we're going to have the measurement of angle 2 is 1/2 of whatever we get when we add up this arc, the measurement of arc JS, and this arc, the measurement of arc PD. These arcs have special names. Welcome. These are called intercepted arcs. Okay. So all of those arcs that are inside of those secant lines, those are intercepted arcs. Okay? And so in words, this formula is that the measure of the angle is half of the sum of the intercepted arcs. It's a mouthful. Okay?
How do you know which one intercepted arc two?
If I'm looking at angle 2, it's going to be this one and this one. So these are all intercepted arcs. This arc got intercepted by this angle. This arc got intercepted by this angle. This arc got intercepted by this angle. Okay? All right. Second theorem for today. I'm going to put a big old star out here in front of our theorem. Okay, so there's 1. We've got 3 theorems. Here's 2. This theorem, we're going to nickname it. This makes it sound like, have you done that knock where you go? Okay, yeah? Right? It comes from a shave and a haircut. I don't know where that is, shave and a haircut. This one makes me feel like that because it's kind of got the same number of syllables, sort of. So this is a secant and a tangent. And I've nicknamed this theorem a secant and a tangent. A secant and a tangent. Because it's going to have
Oh, secant and
a
tangent.
secant and a tangent. And it's going to give us angle measures. Okay, so if a secant and a tangent intersect at the point of tangency, then.
Is it my hair wet?
All right, what is the point of tangency? Look back at your notes from yesterday.
Just sticking
The what?
The point of tangency. What was the point of tangency from our last set of notes? Yeah, it's where the tangent line intersects the circle. So we know that we're going to have a secant, a line that hits the circle in 2 spots, and a tangent, a line that hits the circle in 1 spot. And where those 2 lines come together will be where the tangent actually touches the circle. All right, so let's start with our circle. We're drawing our circle. I'm going to start off by drawing the tangent so I know where that guy is. So there's my tangent line. Here's my point of tangency, which means my secant needs to have that spot as one of its points in the circle. Other than that, it can be anywhere else that we want it to be. Okay, so YOLO, put it anywhere you want. No one cares, just make sure it goes to that point. YOLO. We have a secant and we have a tangent. Okay. All right, we're going to name some dots here. I've got 3 of them, 3 points. I need 3 letters. We had yours. Remind me what yours was from the last example. Chris, what was your letter that we said we were going to hold on to? F. Okay, we'll name this one F. Can I have some other letters?
T.
L.
I heard L, and then I heard from right here T. Okay, good. So now we've got our thing. But I need you to pay attention the whole time. All right, that would have been funny. Okay, here's our formula. Oh, I need to name angles. Let's name this angle 1 and this angle 2. Now this angle 1 goes from here to here, and angle 2 goes from here all the way to here. Okay? Yes? All right. So our formula says this. We have 2 that we can use. The measure of angle 1, which is the measure of this angle right here, is going to equal 1/2 times the measure of this arc right here. Okay? So it's half of the measure of the arc that particular secant tangent thing angle cut. Okay? The other formula that we can create is going to be the same idea, but now we're looking at it from the other side. So the measure of angle 2 is 1/2, but now we need this arc. Now I can't name this arc FT, because if I name this big arc here FT, that's going to tell me to go the short way, because I'm lazy. Okay? So we got to put that extra letter in there so that it tells us we need to go the long way around the circle. So the measure of arc FLT. Okay, so we've got our 2 different formulas that we can use. Bless you. All right. We're all right so far? Okay, so 2 secants, where they intersect inside, we add stuff. A secant and a tangent, they intersect on the circle. There's no addition, it's just a single arc. Our last theorem, I'd like to name 2 lines outside. 2 lines outside is what I'd like to nickname this theorem.
I'm assuming that's one of the 2 lines, like the tangent's like right on the edge, but the line that actually goes through the circle.
Exactly. So he's imagining that we've got a setup where there's 2 lines. Maybe they're both secants. Maybe one is a secant and a tangent. Maybe they're both tangents. But their intersection is definitely located where? Outside the circle. And when we have that setup, we've got a different formula. Okay?
Like if you use figure L or FLT, the point S of the one that intersects T also, like that line, if it was like where the arrow is.
Yeah, if it was way out here. Yep. All right, so here's our setup. We can have 2 secants, a secant and a tangent, or 2 tangents. Intersect in the exterior of a circle, then. All right, let's draw the setups, all three. And can I borrow your colors? Oh, thank you. See, she's super nice. I'm gonna borrow all three of these colors. Okay, so I'm gonna box this setup in yellow. I'm gonna draw that setup here. And then this setup here. I'll take care of it. Thank you. And then I'm going to draw this setup here. Okay. There's my setups. All right, two secants. So I need a circle, poof, and I need two secants, and I need them to intersect somewhere outside of the circle. There we go. There's our intersection. And there are our two secants. So that's what this one looks like. Now we're going to get a secant and a tangent. Draw a circle. I need a secant. And I need a tangent. But this time I want the intersection to happen not on the circle, but outside of the circle. Okay, so there's my intersection. And now I want to draw two tangents. Hey, that one looks familiar, doesn't it? It's our bat signal, yeah? All right. But this one tells us something about angle measures. Oh, it does kind of look like chopsticks, like we've picked up a sushi roll? Yeah. All right, so if we have any three of these setups, we're going to have one single formula, okay? I'm going to add one little symbol. The measure of this angle here, I'm going to use our angle measure variable, which is theta. Okay? Gentlemen, later. Gentlemen. All right, the formula says this. The measure of angle theta, whatever that is equal to 1/2 whatever we get when we subtract, not add. Inside is add, outside is subtract. The big arc's measurements, okay, and by big arc on this one we mean these. The big arc's measurement minus the small arc's measurement. All right. Pretty good? Got our formula? All right, let's practice. Y'all should have this one right here. Okay, so let's bust this out. Let's do these. I think I would love to work on number 24.
Yes, I have a question.
Yes?
For doing the -5, when we do the as perimeter for the bottom, we just put key equals.
Yes.
Okay, so we're gonna do 10-6 and 10-5.
We're working on 10-6. We're going to do as examples out of 10-6. I think I'd love to do 22 and 24. And then probably 17. I think with those three examples, you should be able to get the rest of the page. Okay? All right, so we're going to do 22, 24, and then 17. I clearly don't know how to count. All right, this is your practice assignment 10-6. There might be some at the Pokestop.
Why you messed up the numbers?
Yeah, I did. I can't count. I failed pre-K. Couldn't count. 1, 2, 4, 7. What? I lost. Yeah.
26.
That was me counting in pre-K. This is why I have 9 plus 3 equals 10 as my issues. Did you find it, gentlemen? Oh, great. Thank you. All right. Let's start with number 24. All right. Which of all of our pictures does this thing look like? Does this look like two secants inside,
2 seconds inside.
a secant and a tangent, or two lines outside?
Two secants.
It's two secants. Where are they intersecting? In the circle or out of the
In the
circle?
circle.
Where are they intersecting with each other?
Out of the circle.
Outside of the circle. So we're using two lines outside. The formula for two lines outside says the measure of that angle, which in this case is angle V, is equal to 1/2 of whatever we get when we subtract the big arc. So let's find the big arc. Yep, 100. And we subtract the little arc. I don't know the measurement of that little arc. But do I have enough information to find it?
No.
Yes. Okay. Tell me how yes.
You use X 110.
I can what?
You subtract 110 from 360.
Okay, I can subtract this 110 and this 100
and the 80.
and the 80 from 360, and that should give me the measure of that small arc. 70, you said? All right. So she says 70. I'm totally going to believe her. Those of you with calculators, punch the numbers, make sure she's good. Make sure I'm good.
Yeah, 70.
70. All right, confirmed.
Too slow.
100 minus 70 is 30. And half of 30 is? And that's your answer.
That's it?
That's it. It's really easy. You just got to stick in the formula. It does all the hard work for you.
Oh, I thought you were going to say all you got to do is algebra.
The algebra's on the next one. That's why I wanted to do 22. So let's scoot up and let's do 22 because I don't want you to feel left out with the algebra. We're going to find the measure of arc JP. Let's do it, JP. All right, here's the big arc. Here's the little arc. Is this two secants inside, a secant and a tangent, or two lines outside? Where are they intersecting?
Outside.
Outside. So this is two secants outside. And that formula is the measure of the angle equals 1/2 of whatever I get when I take the big arc and I subtract the measure of the small arc. I wrote it as in symbols this time. Okay. Now we're going to substitute in what we know. What's the measure of angle R? 20. What's the measure of arc KM? Good. What's the measure of arc JP? We don't know. That's what we're looking for. So we can leave it as measure arc JP, or we can change it into our favorite variable. X. Do you want to do that? Okay, we'll change it to X. And so now we're going to... You thought that JP was 20? Notice where the arrow is pointing. Okay. All right, now we got to clear this up. I've got to get rid of that fraction. I don't like the fraction. And I don't want to distribute it, because if I distribute it, I'm going to create another fraction. I want to get rid of it. How do you get rid of fractions in an equation? Multiply? By?
Oh, never mind. I don't divide.
No, you're going to multiply. What are we multiplying by? By 2, by the denominator. It sounded like you were asking, why don't we just distribute? We could. The issue is when I distribute to here, it keeps the fraction. I don't want the fraction. Fractions are annoying. I want to get rid of them. So we're going to multiply everything by 2. All right, so this side is 40. And over here on the left, this multiplication of 2 and this divide by 2 cancel. And it leaves me with 70 minus x. All right, now I'm going to get rid of that 70.
Would be negative 30.
Yep. And now I'm going to, please stop.
X equals 30.
And then I need to clear out that negative, and x equals 30. And so the measurement of arc JP is 30 degrees.
And we can use that same thing for no matter which way it is.
You mean, let me make sure I understand the question. I can use this formula no matter which direction my thing is facing?
You know, if it's tangent.
Yeah, as long as the two lines are intersecting outside of the circle, you're good.
So it's not like each, like if it's two secants or two tangents, or have different
This is not the
formulas,
answer?
it's
Right.
one.
Right, so as long as I've got my two lines, regardless if they're two secants or a secant and a tangent or two tangents,
So the whole top half we can do that.
as long as they intersect outside the circle,
So it's the whole
this
top
is the
half.
formula, the whole top half. All right, let's look at 17.
Is there
Let's look at 17. How many lines do I have? Two. Where are they intersecting? Inside. So I'm going to use theorem 2 secants inside. The formula for that was that the measure of my angle, in this case it's angle 5, is equal to 1/2 of whatever I get when I take this arc, yeah, and I add it to this arc. There's a problem.
Can you just use 90 and
Yeah.
130?
Yes, let's use 90, 130. That's not going to be the measure of angle 5. That's actually going to be the angle of this one right here, the measure of this angle right here. Let's call it
Can
angle
you,
box. Okay?
Can you add all of them or something?
To get to 360? Oh, I see where you're going with that. If I knew something more about how these were related to the others, then yes. But since it's not going through the center, I don't have diameters, I don't know. So by finding the measure of this angle, or this other one, it allows us to create a linear pair right here. These two added together will be 180. So once I figure out what this piece is, I just remove that from 180 and it gives me this piece. Okay? So we're rolling back in our linear pairs from way back when we had two angles creating a straight line. All right. So this angle then, this arc, and this arc, we're going to add those together. We'll finish out this example and then we'll call it done. 220. We'll answer that question in a bit. 220. Half of 220 is? Shh, guys, stop talking. 110?
I had him.
All right, but that's the measure of the box. We want the measure of the angle, of angle 5. Okay? Subtract 110 from 180. And what's the measure of angle 5? Thank you very much.
Is there a way